Alright, welcome to 8.4, solving logarithmic equations and inequalities. We are going to jump right in and start solving some equations. So let's go ahead, we'll call this example 1. Example 1 says to solve. And in problem A, we are given log base 36 of x is equal to 3/2. Alright, so I'm trying to solve for x, but right now x is trapped in the log. So what we're going to do to untrap it is switch forms. So to switch forms, we're going to use that silly trick. We're going to, anytime we see a log, we're thinking logs are B-A-E, which tells us base, answer, exponent. When we switch into exponential form, we know that we have a base raised to an exponent equal to an answer. Now from chapter 7, we can continue to simplify this. So we know from chapter 7 that here in exponential form, what we need to do to simplify this is change it to radical form. So we're going to take this 2 down and around. Remember, we're going to make it a happy problem, that silly trick. So this is either the square root of 36 cubed, or we can write this as the square root of 36 cubed. Now let's think about this. Which one is going to be easier? So if I grab my calculator and I do 36 times 36 times 36. So I have the square root of 46,000, what was it, 656? How many people want to break this down with a factor tree and look for pairs? No, it sounds kind of terrible. So we don't want to use this. Instead, we want to take the square root of 36 and then cube it. So we know that the square root of 36 is 6. When we cube it, 6 times 6 times 6 is 216. So the neat thing about this problem is we went from logarithmic form to exponential form to radical form. So we looked at 3 different forms to solve this problem. So let's go ahead, we'll try another one. Example B. In example B, we are given log base 16 of x is equal to 5/2. Alright, same thing here. I'm trying to solve for x. The x is trapped in the log, so we're going to change forms. When I change to exponential forms, I know that I have a base raised to an exponent equal to an answer. From chapter 7, I know that to solve this, I want to bring that 2 down and around and change this to radical form. So I know that this is the same as the square root of 16 to the 5th power. The square root of 16 is 4, and then to the 5th power, that is 1024. Alright, so the next thing we're going to look at is going to mirror something that we did already with exponentials. So you stay where you're at, and I'm going to go to a previous set of notes. So I'm going to go into 8.2, And do we remember this property from 8.2? It says that two exponentials are equal if and only if their exponents are equal. So we said, if we take a look at an example, here in example 1a, we said, okay, we have 4 to the 8th equal to 4 to the 2x minus 2. The bases are both 4, so we dropped the exponents and set them equal to each other and solved. What we're going to look at now is a very similar property, but it's going to be in logarithmic form. So in logarithmic form, that property looks like this. Log base b of x is equal to log base b of y if and only if x is equal to y. So two logs with the same base are equal if and only if the arguments are equal. So the argument of a log is the x and the y. So it's the stuff that's in parentheses. So let's go ahead, we'll take a look at an example about how this works. So let's call this example 2. Example 2 says to solve and here in problem A we're given log base 5 of 2x plus 5 is equal to log base 5 of 5x minus 4. So with the log property we just wrote down, if the bases are the same, we know that the logs are equal if the arguments are equal. So the arguments are the stuff in parentheses. So we're going to drop down the arguments. 2x plus 5 is equal to 5x minus 4. And now this is easy solving. So go ahead and solve this. Okay, and when you solve this, you should get x is equal to 3. Now, we need to make a note. Okay, so we're going to have to check our answer. We're going to make a note explaining why we have to check our answer. So let's come over here on the side. And we're going to make a note. We're going to just take a look at a simple log, the graph of a simple log. So let's just call this sum log base b of x. So over here on our note, we're just going to take a look just at a simple graph of a log. So I know I have an asymptote right on the y-axis, and I know that it's going to go through 1, 0, and it will look like this. So this is just a basic log. The domain for this log, so So if we think about the domain is x values such that x is greater than 0. Okay, so if I grab my ruler and I turn it towards domain, what that means is that all of these x values where my ruler is, these x values are not included because my ruler doesn't touch right there. Even at 0, 0 is not included in the domain because my function will never touch the y-axis because of the asymptote. It only touches where the x values are positive and non-zero. What that means is that the argument, or the piece in parentheses, okay, so let's write this out. The argument of a log must be greater than 0. Because of the restriction on a log, because of the asymptote, we know that the domain, the x values, have to be greater than 0. So the argument has to be greater than 0. It cannot be 0, and it cannot be negative. So the argument cannot be 0, and it cannot be negative. So what we're going to do when we come over here, and we're looking at this problem, when we say check, so when we say like check our answer, we mean plug into the argument to make sure it's greater than 0. So when we say we need to check our answer, that means we have to take 3 and we have to plug it into the argument of the logs. And we need our arguments to stay positive and non-zero. So what I'm going to do is I'm going to check this in my head. So I'm going to take 3 and I'm going to plug 3 into the first argument right here. 2 times 3 is 6, plus 5 is 11. Is 11 greater than 0? Yes, so we're good there. Let's check the argument over here. 5 times 3 is 15, minus 4 is 11. Is 11 greater than 0? Yes, so we are good here, which means that 3 is an answer. Okay, let's check another one. Or let's do another example. We'll call this example B. In example B, we're given log base 2 of x squared minus 4 is equal to log base 2 of 3x. Alright, so that property said if my logs with the same base, for them to be equal, the arguments have to be equal. So what we're going to do is we're going to drop down the argument. So x squared minus 4 is equal to 3x. And now I need to go solve this. Now, yesterday when I asked the class, I said, how can we go solve this? Somebody said, well, aren't we doing difference of squares on the left? Are we doing difference of squares on the left? What about all the stuff on the right? So because there's something on the right, we're not doing difference of squares, but we are going to do some kind of factoring. What kind of factoring should we do?
Well, you're going to bring the 4 over to the 3x.
Not quite. Good. So we actually want to take the 3x and bring it to the left so that we can use big X. So let's move this 3x over. So I have x squared minus 3x minus 4 is equal to 0. And now we're going to use the big X. So on the top of the big X, remember we're taking 1 times negative 4, which is negative 4. Negative 3 goes in the bottom, and now I'm looking for two numbers that multiply to negative 4, but could add to negative 3. Anybody have an idea? Yeah, what do you got? Good. Negative 4 and 1. Do we need to divide our side numbers? No, because we have a 1 out here. We don't have to divide our side numbers. I can just say, all right, I know I've got x minus 4 and x plus 1. It's set equal to 0, which means I need to set each of these equal to 0. So I'm going to come up with x is 4 and x is negative 1. Now, I'm not done. I need to check the arguments. Okay, so I'm going to check the arguments. So I'm going to take 4, I'm going to start with 4, and I'm going to plug it in here. 4 squared is 16. Minus 4 is 12. Is 12 greater than 0? Yep, so let's check the other side. Alright, we're going to take 4 and plug it in here. 3 times 4 is 12. Is 12 greater than 0? Yep, so 12 is one of my answers. It worked. Now let's check negative 1. Negative 1 squared is 1, minus 4 is negative 3. Is negative 3 greater than 0? No. So negative 1 is not one of my answers. So we're just going to lightly cross it out. It doesn't work. Okay, so this is how we solve logarithmic equations. Now let's start talking about inequalities. So when we talk about inequalities, we're going to take a look at another property. And this one is geared towards inequalities now. So if log base b of x is greater than y, then we know that x is greater than b to the y. If log base b of x is less than y, then x has to be in between 0 and b to the y. Okay, so let's take a look at what this means. So we'll go ahead, we'll call this example 3. Example 3 says to solve and we're going to do an ABCD, and in these examples we're going to look at problems where the argument is just x. So the argument of the log is just x. So we'll start with problem A. In problem A, we are given log base 3 of x is greater than 4. All right, so I want to get x by itself. Right now, x is stuck in the log. So to get it unstuck, we're going to switch forms. And I know that when I have an exponential, I have a base raised to an exponent equal to an answer. So we're going to put our answer, the x part, we're going to put it over on the left. With it being on the left, that means I just get to drop down the sign. So when we put the x on the left, we can just drop down the sign. We don't have to change the sign at all. So I know that x is greater than 81. Let's take a look at another example. Example B. In example B, we have log base 2 of x is less than 4. Okay, so I need to switch forms. When I switch forms, I know in exponential form that I have a base raised to an exponent set equal to an answer. And when I put the answer over on the left, I'm allowed to drop down the inequality. So I have x is less than 16. Now let's think about this. If we take a look up at the log property, when we start with a less than, we have to have the second piece of our answer. So the reason why is, let's take a look at the argument. What's the argument of this log? It's just the what? It's just the x. So the argument of the log is x. Numbers less than 16. Is 0 a number that's less than 16? Yeah. Are negative numbers less than 16? Yeah. Is my argument allowed to be 0? No. Is my argument allowed to be a negative number? No. So we need to make sure that the argument can't be 0 and it can't be negative. So we got to tack on this extra piece. Okay, let's do another one. Let's take a look at this again. So we'll call this example C. In example C, we're given log base 2 of x is less than or equal to negative 2. All right, so currently the x is trapped in the log. So let's go ahead. We're going to switch forms. When I switch forms, I know that I have a base raised to an exponent equal to an answer. So when I put that answer over on the left, I get to drop down the inequality sign. So this is really x is less than or equal to 1/4. Numbers less than 1/4. So is 0 less than 1/4? Yes. Are negative numbers less than 1/4? Yes. My argument cannot be negative and it cannot be 0. So we have to make sure that it's not allowed. So we have to put a 0 as less than x, less than or equal to 1/4. Okay, so we have to ensure the argument's not allowed to be 0 and it's not allowed to be negative. Let's do another one. Example D. In example D, we're given log base 8 of x is greater than 4/3. Trying to solve for x, but the x is trapped inside the log. So I'm going to switch forms. And I know when I switch forms that I have a base raised to an exponent equal to an answer. We're going to put that answer on the left so we can drop down the inequality sign. I know from chapter 7, I'm not done. I can still simplify this. So this is going to, I'm going to drop the 3 down and around. So this is really x is greater than the cube root of 8 to the 4th power. What is the cube root of 8? 2. Okay, and 2 to the 4th power is 16. So x is greater than 16. Numbers that are bigger than 16, does that include 0? Is 0 bigger than 16? Nope. Are negative numbers bigger than 16? Nope. So do I need to put a 0 on this answer? Nope. This answer is good. Because numbers bigger than 16 don't include 0 and don't include negative, so we don't even have to worry about that. What's up? Yes. Now let's take a look at arguments that are not just x. Okay, so let's go ahead. We will call this example 4. We're going to look at arguments that are not just x. So example 4 again is going to say solve. And here in problem A, here's what we've got. We've got log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. All right, so because both of these have log base 4, we can drop down the arguments. So x plus 3 is greater than 2x plus 1. From here, this should be easy solving. So go ahead and solve this for x. When you solve for x, you're going to get 2 is greater than x. In other words, another way to say this is that x is less than 2. Now, the arguments have to be greater than 0. So our arguments have to be greater than 0. So what we're going to do is we're going to set the arguments greater than 0. So the first argument is x plus 3 needs to be greater than 0. And 2x plus 1, the second argument, needs to be greater than 0. And we're going to go solve each of these. When I solve each of these, I get x is greater than negative 3, and I get x is greater than negative 1/2. One of these is going to be what I put at the end of my answer. So I'm going to throw one of these at the end of my answer. Now, there's a few ways to figure out which one we want. The simple explanation is we want the bigger number. What's bigger, negative 3 or negative 1/2? Negative 1/2. So negative 1/2 is the simple answer. It's bigger than negative 3. The reason why we want negative 1/2 is because if a number is bigger than negative 1/2, So somebody choose a number bigger than negative 1/2. How about just 1? So 1 is bigger than negative 1/2. Is 1 bigger than negative 3? Yeah. So a number bigger than negative 1/2 is also bigger than negative 3. But let's think about it the reverse. Negative 2. Is negative 2 bigger than negative 3? Yeah, negative 2 is bigger than negative 3. Is negative 2 bigger than negative 1/2? No. So we choose the bigger number because it encompasses the smaller number. Automatically, any number bigger than negative 1/2 is also bigger than negative 3. Automatically. But a number that's bigger than negative 3 isn't necessarily bigger than negative 1/2. Okay, now the short answer, choose the bigger number. Okay, so the short answer is just choose the bigger number. Now, let's try another one. Sometimes this is a little confusing, so let's try another one. We'll call this example B. In example B, we're given log base 5 of 2x plus 1 is less than or equal to log base 5 of x plus 4. Okay, so my logs have the same base, so I can bring down the arguments. 2x plus 1 is less than or equal to x plus 4. And now this should be easy solving. So go solve this for x. Okay, so we came up with x is less than 3. Numbers that are less than 3. Is 0 less than 3? Yeah. Is our negative numbers less than 3? Yeah, so I know that I have to put something else over here because I don't want x to be less than 0 or equal to 0. So what we're going to do, we're going to set the arguments. We know our arguments have to be greater than 0. So we're going to take our arguments, set them greater than 0, and solve them. So when I solve them, I get x is greater than negative 1/2, and x is greater than negative 4. Which of these is the bigger number? Negative 1/2. So negative 1/2 is going to be what we tack here at the end. Because any number bigger than negative 1/2 is also bigger than negative 4. Any number that's bigger than negative 1/2 is also bigger than negative 4. Okay, let's try another one. Example C. We are given log base 7 of 2x plus 8 is greater than log base 7 of x plus 5. Alright, so my log bases are the same, so I can drop the arguments. 2x plus 8 is greater than x plus 5. Should be easy solving, so go ahead and solve this. we should come up with x is greater than -3. So values that are greater than -3, we don't need to worry about 0, and we don't need to worry about negative numbers, because when we plug in -3, or I guess numbers bigger than -3 will work, because that's what we just solved for. Okay, so we don't have to check negatives, we don't have to set our arguments greater than or equal or greater than 0. So this one we are good because we have a greater than sign. All right, that's all I have for you for 8.4 notes. As always, if you have any questions, watch this video again or feel free to shoot me an email.